Okay, so today we're going to be working on lesson 3 in unit 4 of AP Calculus. Today's lesson is over logarithmic differentiation. So now that we've learned implicit differentiation, we can go back and we can find the derivative of some explicitly defined functions that we have yet to be able to take the derivative of. So for example, y equals x to the x. If you think about it, none of the rules that we learned in Unit 3 can be applied here. Because I can't just say that this is x times x to the x minus 1. That doesn't work because the power rule is only for numbers, not variables, right? So we need to this is bad. Okay? We need to somehow break this apart. So the secret when you have a variable as an exponent is to hit it down with a log. So that's exactly what we're going to do. We're going to take the logarithm of both sides. You may have guessed that from the title of today's lesson. But we're going to take the logarithm of both sides. Now, it's a property in logarithms. We know that the log of x to the b, when we have a power inside a logarithm, now not a power on the outside of the logarithm, but a power on the inside of the logarithm, that we can use log expansion to bring that power down in front. It's a very important property of logarithms. In fact, it's what makes logarithms so great. So that's exactly what I'm going to do. And make this x times the natural log of x. Now, I'm going to take the derivative implicitly because I now have an implicit equation. So the derivative of the natural log of u is u prime over u. So I can write dy dx, but we know that y prime is short for dy dx. So I'll go ahead and use the y prime. So it's u prime over u. So in this case, it's y prime over y. Now, on this one, I need to use the product rule. So derivative of the first times the second plus the first times derivative of the second. And the derivative of natural log of x is 1 over x. Let me draw that over here. So just a little bit of simplification here. We don't normally have to simplify, but I think it makes this problem look prettier. We get that. But we're not done because we haven't solved for y prime. So I've got y prime over y. I need to multiply both sides by y. And I'm showing a lot of steps here that you'll very quickly get to where you're skipping. So do you agree that I have solved for y prime now? But what is y? Well, we know what y is. Y is x to the x. So y prime is equal to x to the x times the natural log of x plus 1. And that's the process of logarithmic differentiation. Typically, logarithmic differentiation is used when you have an exponent that is x and you don't have a base e. We know the derivative of e to the x or e to the u is e to the u prime, but I don't have anything for x to the x. All right, let's try the next one. All right, find the derivative of x to the cosine x. So let's take the log of both sides. All right, so this is the natural log of f of x is equal to cosine of x times the natural log of x by using the log expansion. All right, I'll take the derivative of both sides. And the derivative of the natural log of u is u prime over u. Here we need to use the product rule, the derivative of cosine of x is negative sine of x. So the derivative of the first times the second plus the first times derivative of the second. The derivative of natural log of x is 1 over x. And now our last step, I'll write right here, is to simply multiply both sides by f of x. And when I do so, I'll go ahead and replace. So I get x to the cosine of x times negative sine x times natural log of x plus cosine of x. And there we have it. All right. One more example. Let's do this one. I got an x as an exponent and a base of 3. So let's use the natural log. And I'm going to go ahead and just move that exponent down. That's what we did it for anyway. But make sure you put it in parentheses. All right, we'll take the implicit differentiation. The derivative of natural log of u is u prime over u. And the natural log of 3 is simply a constant. Okay, so I don't need to use the product rule. Natural log of 3 is some number. I don't know what it is, but it's a number. So the derivative of x minus 1 is just 1. And the constant just comes along for the ride. So then this becomes y prime equals y times the natural log of 3. And remember that y is 3 to the x minus 1. Okay, so now what I'd like you to do is do practice 3.1a, b, and c. All right, let's see how we did. All right, so on this one here, we got this is definitely a situation for logarithmic differentiation. So the natural log of both sides allows us to bring that power of 1 over x down. Now I'll take the derivative with implicit differentiation. The natural log of u, the derivative is u prime over u. Here I need to use the product rule. This is x to the negative 1, so its derivative is negative x to the negative 2 times the natural log of x plus, and the derivative of x, natural log of x, is 1 over x. So we get something kind of like that. And then I'll simply multiply both sides by y, and I'll go ahead and replace it. And this is kind of a cool one, so I'm going to actually do this. 1 over x times 1 over x is 1 over x squared. And then we've got minus the natural log of x over x squared. And I think it kind of looks neat. So, but normally, no, you don't need to simplify. All right, let's try the next one. Okay, I've got the natural log of x raised to a power of x plus 4. So we'll use the logarithm to get the exponent down. So the natural log of f of x is equal to, the natural log is going to bring that down for me. And so I end up with the natural log. Let me make sure you see this. It's because I did this. The natural log of this entire side Now, you may have thought, wait, could I just bring that x plus 4 down right at the beginning? But you can't, because the x plus 4 is not inside the logarithms, on the outside. So I had to take another logarithm in order to bring the x plus 4 down. Now we'll take the derivative. I get f prime of x over f of x. That's the derivative of the natural log of f of x. And then the derivative of x plus 4 is simply a 1, so it's going to be the natural log of x. Plus, that's derivative of the first times the second, plus the first, which is a 1, times derivative of the second. Well, the derivative of the natural log of u is u prime over u. So there's the u. U prime is 1 over x. We'll multiply both sides by f of x, and you get f prime of x is equal to f of x, which is natural log of x dx plus 4, times the natural log of the natural log of x plus 1 over x natural log of x. I'll just go ahead and make that, when you take a fraction divided by a whole number, you get that. All right. Y equals x to the x squared. Now, keep in mind, I cannot say, oh, power to power, that must be x to the 2x. I can't say that. If I had x to the x squared, that would equal x to the x times x to the x, which is indeed x to the 2x. But that's not what this is. This is x to the x squared power, which is different. So I need to use the natural log. So this is the natural log of y is equal to x squared times the natural log of x. Because when I take the natural log, I get to bring the exponent down in front. Now I'll take the derivative. I get y prime over y. We'll use the product rule. 2x natural log of x, derivative of the first times the second, plus the first times derivative of the second. And I'll multiply over the y, and the y was x to the x squared times this whole thing. 2x natural log of x plus just an x. Okay, so we can use logarithmic differentiation to find the derivative formula for exponential functions with a base other than the natural base of e. So these two rules, the last two rules that you have to learn for derivatives, for AP Calculus, are actually kind of optional. Because it's not a lot of work to do what we did in 3.1c. That is exactly the kind of problem I'm going to give you a formula for. However, I want my AP Calculus students to memorize this formula because when this gets more complicated, the likelihood of you making a mistake goes up. And it's such an easy problem, we don't want to miss it. So let's derive the formula. The derivative with respect to x of b to the x is b to the x times the natural log of b. So let's do it. I'm going to say that I have a function y equals b to the x. And what I want to find is y prime. So I'll take the natural log of both sides. That allows me to bring down the exponent. All right, taking the derivative of each side gives me y prime over y equals, now the natural log of b is just a constant. So it just comes along for the ride. So the derivative of x is 1, so it's just a natural log of b. Then if I multiply both sides by y, I'm kind of showing all the steps here, I get y prime is equal to the original y, which was b to the x. And that's what I wanted to show. Oh yeah. So that's the formula for the derivative when you have a base other than e. So I want you to notice that any exponential function somehow is tied back to e. Let's take a look at how we would find the derivative given a chain rule. Well, we would simply say the derivative of b to the u is b to the u natural log of b times u prime. So just simple chain rule application. All right, now we can also find the derivative for the logarithms of a base other than e by simply using the change of base formula. Back in Algebra 2, you learned the change of base formula, that the log of base b of a is equal to the natural log of a over the natural log of b. Most students, when they learn this as a way to actually find log. And they may have used the common log base 10. So if I wanted to say find the log base 2 of 8, I would say maybe the log of 8 divided by the log of 2, but I get 3 for an answer because 2 to the third is 8. So we can do the same thing. If I have to find the derivative with respect to x of the log base b of x, well, I don't have that formula. So I'll just rewrite it. That I know that I can always change a base to log of the argument over log of the base. Now, wait, I'm sorry, that should be a bracket, not an equal sign. Now I can do this because the derivative of the natural log of u is 1 over u. So it's 1 over u prime. And the natural log of base b, that's just a constant, right? It just comes along for the ride. So the formula for finding the derivative with a log of a base not natural log is you just simply divide by the natural log of that base. So it's kind of opposite of the exponential one when we times by the log of the base. Now we're dividing by the log of the base. Okay? Okay. So go ahead and find the derivative of, let's see here. We have A, B, C, D, E, F. So you can do them one at a time or you can do them all at once. All right. So we know that the derivative of 3 to the natural log of x, the derivative of 3 to the u, is 3 to the u times the natural log of 3 times u prime. And that's it. Now, you may have used logarithmic differentiation. If you did, that took extra time, and I want you to practice using the formula. But it would work. Like I said, these are actually technically all optional. All right, let's do this one. The derivative of 2 to the u is 2 to the u times the natural log of 2 times u prime. 2 to the u times the natural log of 2 times u prime. All right, the derivative of the log base 3 of u is u prime over u natural log of the base. And that's just I mean, this one here is really not a formula you have to worry too much about. I mean, just remember the change of base formula. That's all it comes from. All right. Letter D. We got 2 to the xy plus x minus y equals 1. We need to use implicit differentiation. And this is where the formula really comes in handy, because otherwise you're going to have to do logarithmic differentiation on the 2 to the xy alone. And we don't really want to do that. So we're going to remember that the derivative of 2 to the u is 2 to the u times the natural log of 2 times u prime. Product rule, derivative of the first times the second plus the first times derivative of the second. And then plus the derivative of x is 1. The derivative of y is dy dx is equal to 0. Okay, I need to distribute. So I'm going to call this y 2 to the xy natural log of 2. When I go there, then I'm going to go here, and I'll say plus x 2 to the xy natural log of 2 times dy dx. Plus 1 minus dy dx equals 0. So close the door for me. So now I will get all the dy dx's on one side. Move all these over the other side. I have, let's see, a negative 1 minus y times 2 to the xy times the natural log of 2. I'll factor out a dy dx. That's a 2, not 2x. And then that becomes a minus 1. And my last step, kind of going to work backwards, go over here, is to divide both sides by what's times dy dx. So it's dy dx is equal to a negative 1 minus y times 2 to the xy natural log of 2 over x times 2 to the xy natural log of 2 minus 1. All right, let's do letter E. All right, so we know that the derivative of the natural log of u is u prime over u. The derivative of log base 3 is very similar. It's u prime over u times the natural log of the base. Then minus 2x equals dy dx. Derivative of 1 is 0, and derivative of y is dy dx. Okay, I'm going to go ahead and multiply both sides by x plus y natural log of 3. Give me 1 plus dy dx minus 2x times x plus y times the natural log of 3 equals dy dx times x plus y times the natural log of 3. So I multiplied each term by x plus y natural log of 3. Cancels out here, so it's just the numerator. Here it's negative 2x times that, and then here it's just dy times that. Then I'll move everything over. Actually, I'll leave it like this. All right, minus dy dx. So I'm going to factor out a dy dx, which will give me x plus y natural log of 3 minus 1. And to save room, I'm just going to divide by that. All right, so that the minus 1 comes from factoring here. Factor out a dy dx to get x plus y natural log of 3 minus 1. So that's what goes in the bottom under all that on the left. Yeah, these are pretty yucky, but they're good for practice. I've never seen stuff this yucky on the AP exam. X plus y natural log of 3 minus 1 needs to divide both sides by it. All right, I think we got one more to do. Arc cosine xy equals x. So I don't really think there's anything particularly new about this one. We should be able to do this before this lesson, right? So the derivative of arc cosine is u prime. Derivative of the first times the second plus the first times derivative of the second. U prime over, it's negative. Don't forget it's arc cosine is negative. Over the square root of 1 minus u squared. And derivative of x is 1. So this one's not too bad. We'll just multiply both sides by a negative 1. Make that plus and a negative, okay? Then I'm going to multiply both sides by the denominator, so I get y plus x dy dx equals a negative square root of 1 minus xy squared. I'll subtract the y, and I'll divide by x. I know I did that kind of cheap style, but it works. All right. For your next practice problem, I want you to please find the equation of the tangent line to x e to the y plus y squared equals 4, where the curve crosses the x-axis. All right, so for this one here, we want to find the equation of the tangent line where the curve crosses the x-axis. First of all, let's find where it crosses the x-axis. At the x-axis, the y-coordinate is 0. So I'll just put a 0 in for y. E to the 0, anything to the 0 power is 1, so that's just x times 1 plus 0 equals 4, so x equals 4. Now I'll take the derivative here. Derivative of the first, we're going to use the product rule. Derivative of the first times the second, so 1 times e to the y, plus the first times derivative of the second. Derivative of e to the y is e to the y times y prime. But when we're doing implicit differentiation, I really want you to use dy dx for a while. Plus, the derivative of y squared is 2y dy dx, and the derivative of 4 is 0. All right, remember that the point here is to get all the dy dx's on one side, and all the terms that don't have a dy dx on the other. Then we'll factor out a dy dx. And we'll divide both sides by x e to the y plus 2y. So this is dy dx equals negative e to the y over x e to the y plus 2y. All right, we're now able to find the equation of the tangent line at the point 4, 0. So dy dx at the point 4, 0 is equal to negative e to the 0 over 4 times e to the 0 plus 2 times 0, which is a negative 1 over 4 times 1 plus 0, so negative 1/4. So our equation is y minus 0 equals negative 1/4 times x minus 4. And that's it for this lesson.